Hello students, this lesson is on geometric sequences. Geometric sequences are created when you are multiplying. So it's different than arithmetic. Arithmetic is when you are adding and geometric is when you're multiplying. So here's an example of a geometric sequence. What you'll notice is that here's my sequence. It's 2, 10, 50, and 250. So you can see that it is growing rather quickly. So that's a good sign that it is geometric. So you want to see what the ratio is, what the common factor is that's being multiplied. So if you go from 2 to 10, we would have to multiply by 5. And when you go from 10 to 50, you're multiplying by 5. And same thing when you go from 50 to 250. So the multiplying by 5, this is called your common ratio. And we use the letter R to stand for that. Now when you first see a sequence, if you can't figure out what the ratio is, then just like with the arithmetic, you want to pick a pair. And you're going to go backwards. So going backwards from multiplying would be to divide. So pick a pair and then just divide them. And that'll get you your common ratio. Okay, so let's start off relatively easy. These first two examples, we're going to find R, which is the common ratio, and we're going to find the next four terms. So the first thing that you want to do is you want to figure out what the common ratio is. So to go from -4 to -16, you would have to multiply by 4. And then just check and see if that's going to be the same case for each in between each number. So from -16 to -64, multiplying by 4. And from -64 to -256, you're multiplying by 4. So your common ratio is the number 4. And then now they want you to figure out what the next four terms are. So multiply -256 by 4. And the next term would be, we're going to put 3 dots to show that this is the next term, so -1024. And then multiply that one by 4, and you'll get -4096. And multiply that one by 4, you get -16,384. And one more to get 4 terms, and that would be -65,536. So there's your next 4 terms. Okay, I want you to do this next example. Try and do it on your own, and then press play when you're ready to check. Okay, so here's what I got on example 2. Your common ratio is 1/3. Now if you put that the common ratio is 3, pay attention to what's happening to the sequence. The sequence is going down in value, so the common ratio is going to have to be a fraction. And if you couldn't figure out what it is, remember to pick a pair. So I just picked 243 and 81, and you want to go backwards. So you want to put 81 and divide it by 243. When you simplify that, that comes out to be 1/3. And then go ahead and figure out what your next 4 terms are. Okay, so for our next 2 examples, we're going to write both the explicit and the recursive formulas, and then we're going to generate the first 3 terms. So from your formula chart, the explicit formula is it's a sub n equals a sub 1 times r to the n minus 1 power. So if we're taking what they've given us in example 3, then our explicit formula is going to be a sub n equals 1024 times negative 0.5 to the n minus 1 power. And remember, this explicit formula is used when you're trying to jump to a certain term. Like if they wanted you to find the 100th term or the 20th term, then you would use your explicit formula. Okay, the recursive formula is used when we're trying to build the sequence. Recursive means to build. And you need to have two things for that. Number one, you need to have what a sub 1 is, which they've given us. It's 1024. And then the other part of the formula is a sub n equals the rate, or the common ratios, so the r. So we're going to put in a negative 0.5, and it's just times a sub n minus 1, which is considered the previous term. So here's our recursive formula. And then now let's go ahead and build our first three terms. So our first term is 1024. And if I multiply that by negative 0.5, then I'm going to get negative 512. Multiply it by negative 0.5 again, and you get 256. And there's our first three terms. Just put the dots on the end to show that it's going to keep going. Alright, so you go ahead and do example 4, and then press play when you're ready to check your answer. Alright, so here's what you should have gotten on example 4, so check your work and make sure that you have it correct. Okay, in these next two examples, we're going to find the middle term of the geometric sequence. When you're trying to find the middle term of the geometric sequence, this is called the geometric mean. So when you were looking at, in the previous lesson, we looked at the arithmetic mean, but since these are geometric sequences, then it's going to be the geometric mean. So the formula for that, and it is on your formula card, and that's just to take the two terms, multiply them together, and then take the square root of that. So the square root of 12 times 3 is the square root of 36, which is 6, or negative 6. And it's very important that you include both 6 and negative 6, because you're not sure, we're not sure if the ratio is a positive or a negative, so we want to include both of them. Alright, so if we do the second example, the example 6, we're going to multiply them together. So 28 times 5,103, and then we're going to take the square root of that. And so I'm going to use my calculator, and that comes out to be 378, or negative 378. Okay, is the following sequence arithmetic, geometric, or neither? So we're going to look at this sequence, and we're going to see if we can figure out which one it is. So if you look from 2 to negative 1, you can either think of that as subtracting 3 or multiplying by a negative half. So see what happens with the next group. So from negative 1 to 0.5, that's not really subtracting 3 again, so it can't be arithmetic. So let's see if it would be multiplying by a negative 0.5. So let's see. 2 times negative 0.5 is negative 1. Negative 1 times a negative 0.5 is positive 0.5. And then times a negative 0.5 again, and that's negative 0.25. So it does look like it's geometric. And the common ratio is negative 0.5. And then we're going to go ahead and find the next two terms. So if we multiply negative 0.25 times a negative 0.5, we're going to get 0.125. And if we multiply it again, then we're going to get negative 0.0625. And then it's going to keep on going. Alright, so let's look at the next example. Going from 5 to 6, you would be adding 1. Going from 6 to 8, you'd be adding 2. So we can already tell it's not going to be arithmetic. So now we just want to check geometric. Well, 5 times 6/5 would give us 6, but 6 times 6/5 does not give us 8. So this one is neither. It is neither arithmetic or geometric. Okay, these are the last two examples. We're going to find the 11th term. So in example 9, we have negative 14, negative 42, negative 126, negative 378. You always want to double check and make sure that it's either arithmetic or geometric. You can tell that it is growing. The common rate of what it's being multiplied each time is a 3. So my common ratio is 3. Now when you're trying to find the 11th term, you're using the explicit formula, which is a sub n equals a sub 1 times the r to the n minus 1. So we're going to try and find a sub 11. The a sub 1 is negative 14. The r is 3. And then our n is 11. That's the number we're trying to find, and we're going to subtract 1. So if you use your calculator to figure out what this is, it comes out to be negative 826,686. And that is the 11th term. Alright, so you go ahead and do this last example, and I'm going to have you fill out what the answer is on tonight's WISC. Alright, have a good evening, and I'll see you in class.